Question for the grade 8 exam that I was asked to go over. So it says the city of Mayo is hosting its annual mountain bike race. The diagram below shows a top view of the mountain bike race path. The race consists of biking around the race path once. So you have to go around this perimeter once, okay? And it's talking about the dark, like this dark part around the outside. So the area around which the race path was designed can be divided into three zones: a circular sector, a regular hexagon, and a triangle. So that's actually really nice that they told you what those shapes are. You should be able to identify here that like you have a circle, you just don't have the whole circle. You have a hexagon in the middle and you have a triangle on the side here, okay? And it specifies that it is a regular hexagon, which means all of the side lengths are the same. It says, in addition, segment AB measures 5 kilometers. So that's what they've marked here, saying that this is 5 kilometers. The apothem of the regular hexagon measures 6 kilometers. So they tell you this is the apothem. You should be able to recognize that. The area of the regular hexagon, oh, you can't see any of this. I'm just going to scroll down a bit here. Okay, so 5 kilometers, 6 kilometers. The area of the regular hexagon is 126 kilometers squared. So that's something that we're going to use to work backwards right away. And the sum of the interior angles of a hexagon is 720 degrees. Again, that's really nice. They did not need to tell you that. You should be able to figure that out using the formulas that we learned in class. So it says point D is the center of the circle. And you need to figure out to the nearest tenth of a kilometer what is the total length of the mountain bike race path. So you have to figure out what the length is around this whole thing. So the first thing that I'm going to do here is recognize that in this triangle, these two angles are both 40 degrees, which means that this is an isosceles triangle. So this side is also 5 kilometers. Okay, second thing I'm going to do is I'm going to work with my area of a hexagon to work backwards and figure out what the side length of this hexagon is, okay? And all of these sides will be the same. Once I get that side length is also going to be the radius of my circle, okay? So even though like these side lengths are all the same, right? And we need these three pieces, but we also need it because this, which is the side length of the hexagon, is also my radius of the circle. Okay, so first thing I'm going to do here is I'm going to plug in the formula for the area of a hexagon. So it is apothem times perimeter divided by 2. So I don't have the perimeter, but I do have the area and I do have the apothem, so I can work backwards. So this is going to be 126, which was given to me, is equal to apothem, which is 6 times p, so p will be the part that I don't know, divided by 2. Okay, there's more than one way you could do this now, so you're just solving an algebraic equation here. So 126 equals 6p divided by 2. I can either do 2 times 126, or you could do 6 divided by 2 right away. So I'm going to go ahead and do 6 divided by 2 because it's easily divisible. So 126 is equal to 3, because I did 6 divided by 2, p. And then the last thing I'm going to do is divide by 3 on both sides. Okay, so you can do that. If you need to do it on your calculator, you go ahead, you have your calculator with you, but this is going to be 42. Okay, so that means that the perimeter of my hexagon is 42. So if there's 6 sides and the perimeter is 42, then I'm going to do 42 divided by 6 to figure out that the side length is 7 kilometers. So that means that each of these are 7. Okay, we're not going to add up all of them. We are only going to add up the ones that we need from in there. But it also means that my radius is 7. So because this side length, like we said, this is 7 kilometers, this side length. And that's my radius of the circle. So I have what I need from the hexagon right now. I'm going to move on to the circle. The thing is, you don't have the entire circle. You have the sector of a circle. So you're talking about a piece of a circle. You are responsible for knowing that an entire circle is 360 degrees, okay? But we're going to find the circumference of the circle, and we're going to use the arc length formula to figure out just this part. So the last piece that you would need to recognize here is that it said down here that the interior angles of a hexagon are 720 degrees. Okay, so that means all of these angles add up to 720. Well, if I do 720 divided by 6, because there's 6 angles in there, it will tell me that each interior angle is 120 degrees. So that means that these are all 120 degrees. And what that helps me with here is that if this interior angle is 120 degrees, I can subtract that from 360 to figure out what the angle is for the arc length that we're going to use, okay? So I'm going to do 360 minus 120 degrees is equal to 240. Okay, so I really should have kept numbering my steps here. So I did this, I figured out the side length. I'm going to call this number 3 down here, figuring out the angle 4. So my angle is going to be 240 degrees. So that's 240 degrees here. Okay. My next thing I'm going to do, again, you have way, way, way more space than this to work on your exam because you have an entire other page, okay? I'm going to do the circumference of the circle because we're still trying to figure out the perimeter. The word for perimeter when we're talking about a circle is circumference. So you're going to do circumference is 2 times pi times r, which is radius. Again, don't get freaked out about pi. You can either write 3.14 in your calculator if you need to, or if your calculator has a pi button, then you just press the pi button. Okay, so here is circumference equals 2 times pi times the radius, which is 7. So you should have ended up with circumference equals 43.98. Again, it's normal if it's slightly off from there. So it's possible that you have like some discrepancy if you use the pi button or if you use 3.14 or wherever you decide to round with your pi button. So it might be slightly different here, but it needs to be within that ballpark. So that's the circumference. The next thing I have to do is figure out my arc length. So you have a formula for arc length on your memory aid. It should be on your memory aid anyways. So you put the angle over 360. So in this case, 240 degrees over 360. And it's going to be equal to the arc length, which is what we're looking for, over the circumference of the circle. So over 43.98. So again, you're cross multiplying. You're going to come to 29.32 as the arc length. So all of these measurements are in kilometers. But so what that's telling you is that this part of the circle around all the way around here is 29.32 kilometers. Okay, so that is the part that goes from here to here because you were using this 240 degrees for your arc length. Okay, so now all that's left to do, if you have all of those pieces, is to add them up. So I like to start somewhere, since I already circled this 5, I'm going to start there because I like to circle them as I add them to make sure I don't miss anything when you have all these pieces, okay? So I'm going to start with this 5 and I'm going to go this way all the way around. So I'm just going to add up everything from the outside. So 5 plus 7 plus 29.32 plus 7 plus another 7 plus another 5. Okay, and when you add all of that up, you should have gotten that the perimeter of the entire thing is 60, and it's said to round it to the nearest tenth, so it's 60.3 kilometers. So you can see here that I had a 3.2, but you're supposed to round it to the nearest tenth, which is this position. So it's 60.3. Okay, and then that's your final answer.